As we continue, we're picking up right where we left off in part one. We looked at these two graphs, we applied the vertical line test, saw this one was not a representative of a function, this one was. So now that we saw that was, let's come back to the notation. I do have a little bit marked up, so we'll do a couple of examples here, but first thing, just to get a few points established, the notation, that if I establish this graph represented function f, and by the way, folks, that's a huge advantage for this notation. If you see this notation, there's no question, is this a function? We're not sure, again, there's no gotcha question here. If you see that, whether you have an equation or you have a graph, having that notation makes it clear that it represents a function. But now, if I give you this and I say, find f of 3, what are we doing here? When I asked you to do that back here, we found, where was it, f of 4. We plugged 4 in for the x, sorry, it was over here. We plugged 4 in for the x that went with that equation. But now, I don't have an equation. So what am I supposed to do with f of 3? This is where we have to understand what the notation is saying. It's saying, in function f, when x is 3, what is the y? When we had the equation, we had to plug that in to figure that out. But with the graph, that's actually easier. I just look. When x is 3, 1, 2, 3, there's x is 3. There is the point on the graph that goes with that x, the 1 point, and then that is the y that goes with it. That y value, 1 unit below the origin, would be a y of -1. It's just that simple. What is f of -1? Well, now, that is x is -1. That is the point on the graph. Very roughly here, we'll say that line's up here. That is 1 point above the origin. So f of -1 is +1. So we'll do more with that in just a moment. But then still sticking with this picture, let's get to our next two terms. Let's talk about the concept of domain and separately the concept of range. Not to take things too far, folks. For our book, they pretty much always write it out, domain and range. But just to try and point out, there's some nice, easy notation. Capital D sub f makes it very clear you're talking about the domain of function f. Capital R for range of function f. But again, our book is very nicely always writes it out. That's more for people who go to pre-calculus. That'll be something you'll need to get used to. But the idea is very simple. The domain, the range, we talked about a function having two important categories, having the input variable and then the output variable, having those two separate components. The domain and range are looking at each one individually. That my domain is looking at the collection of all inputs. So again, the collection of all x's. And then the range is then the collection of all the y's, of all of the outputs. But in order to do that, we have to notice a very, very big distinct difference. Again, back to this problem. We were asked these questions. We had the notation in function f, when x is 3, what is the y? That could be understood in the same way as that xy ordered pair. But that ordered pair represents a single point, just like we are seeing up here. But now when we talk about domain and range, I'm not just looking at 1 or 2 x values or 1 or 2 y's. I'm looking at a whole set, a whole collection. I'm looking at an entire interval. So this is where it's just understanding the context. When we look for domain and range, we expect that our answer is going to be an interval, so I will need interval notation. So again, I know this one is getting messy, so we'll just finish up here and then we'll do some fresh problems in just a moment. But looking for the domain and the range, the domain, what are all the x's that are being used? Well, I look, I'm using a bunch of x's. I'm using that one, that one, that one, that one. So let's try and be ordered. I'm going to look at the leftmost x. That would be right here. And that was filled in, so that makes that filled in. To my rightmost x point, that would be up here. That was an open circle, so it'll come down as an open circle. And there's no breaks in the graph in between, so I'm using every x in between. Again, I know this picture is getting messy, but it still gets the idea across. My domain, I need the interval from this x to that x. This x, 3 units to the left, that's -3. Filled in circle gets the bracket, comma. Over here, we're looking at, what is that? 1, 2, 3, 4, 5. X is 5. And that is an open circle, hence that gets a parenthesis. Now, just having the bracket here helps separate an ordered pair from an interval. But if that was an open circle, that would be an open circle. That would be another parenthesis. So again, it's the context. Understanding that this, in this context, represents an xy. Domain, there is no y. The domain is just the x. I'm getting this whole group of x's. And then same thing for the range. Except now the range, now I'm looking at y's. Bottom y to top y. Now some people kind of get lucky. They see this point and this point were kind of the keys for domain, so then they try and use that same thing for the y's, but that's just kind of a lucky coincidence here. We're really just looking for my bottommost point. Oh, there it is. That lines up here. To my topmost point, and that's why this one's deceiving. This is my actual top point. And that was a filled in bubble. So now my range is going to go from here up to here. The y values, this is the one little thing to get used to with your interval notation. For x, we're still going left to right, just like we did with our number lines when we were dealing with inequalities. But now for range, we have to get used to the orientation bottom to top. I'm starting down here, 1, 2 units below at -2, and I'm finishing up here 2 units above at +2. Both are filled in, both get brackets. So again, that was a little messy here. We were starting to see a lot, and I still want to add just a tiny bit more. Again, this is where all the characteristics, once we have a graph, there's a lot of little things that we might be asked to look for, and that's what I was saying at the very beginning of this section. The individual problems aren't so hard. It's just keeping track of all the little terminology and having those right expectations to know. Something like this, I expected just a number answer. Something like this, I expected an interval answer. So the next part, our last couple of terms we need, we're going to talk about what we call the intercepts. Specifically, we have 2 different ones. We have the x-intercepts, and we also have the y-intercepts. Intercepts are defined as points. Specifically, the x-intercept, the point, or points plural, where the graph crosses or touches the x-axis. And then my y-intercept, very similar. This will only have one, will be the point where the graph crosses the y-axis. So coming back looking at this one, where do I cross or touch the x-axis? Again, I know it's messy, so I'm not going to write it out. We'll do a fresh one in just a moment. But where do I cross or touch the x-axis? I cross here, I cross here, I cross here. That gives me 3 separate x-intercepts, but again, they are points. That point, a lot of people say x equals -2, but that's just an x-coordinate. The y-coordinate would be 0. You didn't go up or down, you're on the x-axis. Similar here. That would be 2 comma positive 0. I'm sorry, positive 2 comma 0. Now it's 2 units to the right, but still on the x-axis, not going up or down. And one more here at 4 comma 0. Crossing the x-axis one more time. The reason I emphasize touch, if it just did this, it doesn't have to cross through the x-axis. It's still touching the x-axis. That would still count as another x-intercept. As far as my y-intercept, this is where I don't know how many x-intercepts I might have. I might only have one. I might have none. But it's just about how many times we cross the x-axis, cross or touch. That can happen in a lot of different ways. But if we're dealing with a function, it already passed the vertical line test, so it can only cross the y-axis, which is a vertical line, in just one spot. And here, we see it right here. And that would have a y-intercept 0 comma 2. It's on the y-axis. I'm not going left or right. I'm going 0 units in the x direction, but I'm going up 2, so positive 2 for the y. Again, same thing. It's very tempting to just say y equals 2, but that's a little bit incomplete. It is asking, it is defined as a point, so we should write it down as a point. So now let's get some more practice. We got a lot of little aspects, so let's get practice with a bunch of them. So let me just start off with now a fresh graph. This is my new f of x. And my function does this. That's it. Just very simple. What are we looking at? Well, let's get a few of those trickier points. Let's again do our domain. We'll do our range. We'll look for any x-intercepts, and we'll look for any y's. How do we do this? Well, just like we were seeing before. My domain, I'm looking for the x's. I'm starting here on the left at this point, and it's filled in, and I'm ending here on the right with this open circle. I'm filling in everything in between, and I just need an interval that's 2 units to the left of the origin, that would be minus 2, to 2 units to the right of the origin, to positive 2. That's filled in, gets the bracket, open, gets the parenthesis. For a lot of people, this idea of domain and range, it's about squishing your graph, squishing it up or down onto the x-axis for domain, and then squishing it left or right onto the y-axis. The only thing that's a little troubling with that, some people, like I go to squish this onto the y-axis, people are like, well, what if it bubbles? What if it oozes? That's where it can throw people off. It's just a literal push. This was right here. I am pushing it to the right onto the y-axis. This is up here. I'm pushing it to the left, and everything in between is going similarly. So this point marks off my bottommost point, filled in. This point marks off my topmost point. That's an open circle. We are looking at this interval. 1 unit below the origin, that'll be a minus 1 for y, to 2 units above, that'll be a positive 2. Filled in here, bracket, open up here, parenthesis. X and y intercept, x-intercept, we've got 1. It's right there. That's where we cross the x-axis. That happened 1 unit to the left of the origin. Again, that's not an interval. That's not saying minus 1 to 0. It's just identifying that point. And I have no confusion because I understand that answer only makes sense as a point, whereas up here, again, it's not about just having the bracket. If that was an open circle, that would have been a parenthesis, but I still would have understood it as an interval of x's because that's what domain stands for. Similarly, for my y-intercept, again, it's messy. It was right here, just 1 unit up, so that would be 0 comma positive 1. Be careful with your x's and y's. It's very easy, like I was saying in the beginning, to goof up the order. People say, hey, I'm looking for the y here. They get y as 1, and they want to write 1 comma 0. This is the coordinate 1, 0, and that has nothing to do with this graph. So it's 0, 1. Let's take this a little bit further. Same graph, but now, instead of having this open circle, this line continues and I've got this arrowhead. We have to understand that when we see an arrowhead, that has some aspect of forever to it. That in the earlier example, I had a very clear start and stop point with those filled in or open circles. And some people misunderstand because we need to emphasize that was filled in, that was open. In between, people wonder, well, what about the other stuff? Everything in between is a filled in point. It's just we need that extra emphasis on those original or finishing points. But when we see an arrowhead, we got to realize that has the understanding of continuing forever. So people try and do the same thing. We didn't change the x or y intercepts. They're fine. But the domain and range. I'm still starting at this point at -2. But now some people see this and just go, oh, okay, now he's ending here. So that's 1, 2, 3, 4. It's -2 to 4. But that's the misunderstanding on what's supposed to be happening here. The idea is that this is an arrowhead, that this doesn't stop. It continues forever in that direction. It keeps going to the right and it keeps going up. So right now, for the idea of domain, I care about the x's. Still starting here, but I'm not finishing here. This keeps continuing and it keeps continuing this way forever. We still have the concept of infinity coming up. Still starting at -2, but now it finishes at positive infinity. And similarly for the range. My range, well, my lowest y is still right here, but now my highest y, it's not here. Again, my dash has got a little messy here, but if you go back to the original, you'd count up 1, 2, 3, 4, but that's not ending at y is 4. That keeps going up. It's not going up fast, but it still keeps going up. So I'd eventually get to y is 5. I'd eventually get to y is 6. And it keeps going up forever so that this starts down here and keeps going up forever. This range also finishes at positive infinity. Let's just stick with domain and range for the next one to really make sure we're getting the good understanding here. Let's look at this for my next example. Let's now make this function g, just to use a different letter. And that now my function does this. So there's a new function. Again, it's got the function notation already, but even if we went back to the beginning, this would pass my vertical line test. No vertical line hits the graph in more than one spot. So the thing we need to do here, still asking for domain and range. So still same concept as before. Domain, what are my x's? What is my leftmost x to my rightmost x? And like we just saw in that previous example, if you don't understand the arrowhead, this is where it's easy for people to just say, okay, that's my leftmost point. It's at -4. That's my rightmost point. I'm sorry, -3 here. 1, 2, 3. That's at -3. This point furthest to the right, that's 4 units to the right. But again, that's misunderstanding the arrow. That arrow keeps going in that direction. So that arrow is taking me both left and up forever. So my domain, what is my leftmost x? Well, again, take away the up part, this keeps going left forever. But on this side, that is a clear finish point. That would be my domain. Starting left to right, left forever would be negative infinity to this point, which is clearly x is 4. Oh, I'm sorry, and that's a filled in, so I would get the bracket on the 4, not the parenthesis. But now my range. And now twofold here. Some people still have little misunderstandings with the arrowhead. But the second thing, this is what I was saying before. We have a nice left to right setup so people see this is a left point, this is a right point, and that can help some people with domain. But then they go to do range and they ignore bottom to top and they just go, okay, well, this point is at this Y, this point is at this Y, and their range is in between. That is completely missing the idea of, again, bottom to top. And let's actually even take this a little lower here. Let's make this one. Didn't change the original part, right? It's still left to right, so negative infinity to here, positive 4. But now my range, it's not here to here. I'm looking my lowest point to my highest point. That is my lowest point. I know it's in the middle of the graph, but when I'm talking about range, I don't care what's in the middle, what's on the edges. I just care what is my lowest point, and that is right here, to what is my highest point, and now it's not here. That's where, again, this keeps going up forever. So my Y's keep going up forever. I'm going from here up forever here. I'm looking at, what is that? 1, 2, 3 down. So negative 3 with a bracket up to positive infinity. That's where we get a little bit more practice to get better uses of the infinities and to not have coincidences. This is going both up and right forever, led to both these being infinity, but on this side, well, the up forever gave me the infinity here, but the left forever was actually the left endpoint here. So again, this is a good practice of just making sure you're clear with your intervals and that you're doing your correct left to right. All right, so that really ends this section. We want to do one more problem together because there was a lot of ideas. Let's mix it all together for our last one. I've got this function and I've got all these questions that I want to ask to go with it. So take our time. I'm going to try not to make my graph too messy so we could look at each one of these one at a time. So starting off, picking up where we left off, domain and range. Starting off with my domain, my leftmost x to my rightmost x. No arrowheads this time, so nothing too fancy. Left to right. That's my leftmost point, there's my rightmost point. I'm starting here at 1, 2, 3, 4 to the left. That would be negative 4. Finishing here, 1, 2, 3 to the right, positive 3. That was filled in, gives me the bracket here. That is open, gives me the parenthesis here. My range, and this is just what I was talking about a moment ago. These points were the left and right endpoints. They are not the up and the down endpoints. People just go that Y to that Y, and then they have no idea what to do with that. But it's not. That's not my lowest point to my highest point. This is my lowest point. This is my highest point. My lowest point here at a Y, 3 units down, negative 3, to my highest point here, a Y, 3 units above, to positive 3. Both filled in points. I try to put a little emphasis here that they're filled in, but this is what I was saying before. The only open circle is right here. If I care about this point, it's filled in. If I care about this point, it's filled in. This point is 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 filled in. They're all filled in unless they are especially emphasized that they are open circle. So filled in, I'll include the negative 3 with a bracket. To filled in here, the bracket for the positive 3. Now some of the basics of function notation. I'm giving you an x. No extra explanation. We need to understand it's asking for the y. If you have an equation, you're plugging that x in and doing the work. But on the graph, as long as you understand the concept, this goes faster. I just look, where is x is negative 4? Here it is, 1, 2, 3, 4 to the left. Where is the point on the graph that goes with it? Here it is. What is the y that goes with that point? It's a y of 1. How about f of -1? Well, now I'm going to x is -1. Where's the point that goes with that x? Here it is. There's the y that goes with it. 1, 2, 3 units down. That'll be a y of -3. Notice in these two, that's the proper way to answer this. We talked earlier, this really is an xy pair, but this is the better way to leave it and have your notation. I understand what people are doing. People try and do this equals -4, 1. You're doing a little too much with the notation. You already have the x coordinate, you just give the y, or you just write the xy pair, but you don't put an equals back to this. So again, better habit, leave the notation, just give the y. Leave the notation, just give the y. How about this one? X is 1, what's the y? Well, there's x is 1, and there's my point. I'm not going up or down, I'm just right there, right on the axis. The y is 0. Last couple. Oh, this is the one we haven't kind of seen yet. The reverse. With this notation, I don't have to write much out. We understand the notation, giving you the x, asking for the y. But now the question is trying to reverse that question. What is the value of x such that f of x is 3? That's really just reversing it. X is what such that y equals 3. So reverse it. Find y is 3 first. That's up here. Now I'll look left, right for the point that goes with it. Here it is. What is the x that goes with that point? Right here. X is 2. This point is 2, 3. So if I said what is f of 2, x is 2, the y is 3, this one is just trying to reverse the question. But again, there's no fancy way to do that with notation. You have to spell it out like that. But now for you, again, you have to make that connection. What are they asking? Oh, y is 3, what is x? Last two, my x and my y intercepts. My x-intercepts, where we cross or touch the x-axis, I see that up here. I'm looking at my graph. I am crossing the x-axis here and here. Two answers. Again, let me point out the common little mistake here. People go, x is that one, they see -3, and they come here and put 1, incomplete. Even worse, people put an ordered pair around it, they put their parentheses, and now they're talking about the point -3, 1, which is just here. That has no connection to the graph. So again, good habits. You know what you're looking for, how to put your answer in the proper form. Use the point notation, x, y pair. That x is -3, the y is 0, and then that x is 1, the y is also 0. Two separate x, y pairs for two separate points, two separate x-intercepts. The earlier one, we saw 3 x-intercepts. You'll see some examples in the book that only have 1 x-intercept. It might not even touch the x-axis, and it has no x-intercepts. Anything is possible. We're just looking where it crosses, touches, and each problem is its own case. But now y-intercept, sept, singular, there's only one. Where do we cross the y-axis? And in this one, right here. That's it. Cross the y-axis right there. But again, don't just use the y notation. We're going to see more. That's troubling. That means something else entirely. So once again, x, y pair. Just be clear, this time the x coordinate is 0, and then the y is -2.